Okay, good morning, everyone. Okay, any questions before we start? Okay, I'll look at those. $15. Okay. Okay, 15, 30, and 41. Now 15 and 30 are very much alike. So I will pick one of them. Okay. So I will look at 15. So we have the following: x squared plus 2y squared minus 6x equal to 0. Okay, and the question is, yeah, I've seen number 30. So 15 and 30 are very much the same type problem. So I will pick 15 and I will leave 30 for you guys to do it for tomorrow. Okay, because I want to finish hyperbola today. So let's look at this. So this is tell us that find the equation, find the vertices and foci of the ellipse and sketch its graph. All right. So as I said, this is the type which is an ellipse given in this guise. So we have to rewrite it so that we get a real ellipse out of it. Okay. So the first thing we do is we're going to collect the axes. We put the axes together and collect the y's. And we put the constant term from the other side. Okay, and the idea here is completing the square to be able to get to the standard form. All right, so x squared minus 6x. I want to complete the square here. Okay, so it's x squared minus 6. To complete the square, I have to add, okay, x is multiplied by 6. 6 divided by 2, it's a 3. I square it, and I add it, minus 9. So I took care of this piece. Now, I need to complete the square here. Our algorithm that we take the coefficient of y and we divide it by 2 work as long as the coefficient of y squared is 1. So to be able to do that, I'm going to factor out the coefficient here. So we always do this so we can apply our algorithm. Equal minus 7. Okay, now this piece is already a full square. So this is minus 9 plus. So I'm done with this piece. This one here is y squared plus 2y. To complete the square of this inside, I need to add 1 and I need to subtract 1. Okay, very good. Now we're on almost on our way. Minus 9 plus 2 times. This now is y plus 1 square minus 1 equal minus 7. So finally, I will get x minus 3 square minus 9 plus 2 times y plus 1 square minus 2 equal minus 7. We're distributing at this stage. So we're getting, so that's 2 times y plus 1 square equal minus 7. Now minus 2 minus 9, that's minus 11. And I'm going to add 11 this side. So I will have this expression plus that equal to 4. Now I divide by 4 because I want to get to the standard form of an ellipse. I divide by 4 across the board. I will get x minus 3 squared over 4 plus y plus 1 square over 2 equal to 1. And that's what we call the standard equation of the ellipse. So that's the standard equation. Once I have the standard equation, I can actually answer every question I want about the ellipse, but that's really the most important step, because now we see the ellipse. So now the center is 3 and minus 1. Okay. Now here the a square is 4 and the b square is equal to 2. So a here is larger than b, so this could mean that my ellipse is going to be elongated horizontally, not vertically. All right. Now the foci. We need the c. So the c square is 4, it's the largest, minus this, which is equal to 2. Now the vertices and the foci, and for that I have to draw a little bit to see what's really going on. The center is at 3 and minus 1. So that's really where my center is. A square is 4. It means the a is 2. So a is 2. A is how far we are. So this is a 3 here. So we have to go 2 units from each side. This is a 2 and a 2. So those will be the vertices in our scenario. B square is 2. It means B is the square root of 2. Square root of 2 is a little bit more than 1, somewhere like this. So my ellipse, that's my ellipse.
How much did you go up and down by?
A.
Oh,
A
so.
and B. Whatever your B is. My A is 2. My B is the square root of 2.
Oh, okay, okay.
Okay?
Yes.
Always. We move from the center, we move horizontally by A and vertically by B. Okay, so now the vertices. The vertices are those 2 points. So according to the picture, basically, the y is a minus 1. And the x, this is a 1 from here. And this is a 3. You add 2 to it, you get 5. And the foci. Now the C is right here. That's my C. So the C square is 2. C is the square root of 2. So that's the C. That's the square root of 2 and the square root of 2. So the foci is going to be the following. Everything is on the line y equal minus 1. It's going to be the center plus the square root of 2, the center minus the square root of 2. Okay? Number 30 is exactly the same, and if you want tomorrow, I will be glad to go over it. Questions before we move on? So let me have a quick look at 41 and then we proceed. So quick look at 41. 41 is what? Find the equation of the ellipse. So we have to find the equation with a center at 2, 2. That's the center. And the focus is 0, 2. And finally, what else they give us? Vertex is 5, 2. Okay. So the equation is x minus, since this is the center, it means the equation will be x minus 2 square divided by a square plus y minus 2 square divided by b square equal to 1. And the question is, we need to find the a and the b. Okay, that's to find the equation. All right, so let me draw a little bit those picture because this helped me out. So the center is at 2, 2. That's my center. My foci is 0, 2. 0, 2. So it means that if this is the center, this is the foci, this is the C. So they gave me the foci. 0, 2. Now the vertex is 5, 2. Remember, this is 2 and this is 2, 5. It means 2, 3, 4, 5. So from here to here, we have 3 units. That's the A, which is equal to 3, because these are the vertex. Now, after that, I'm done. So I'm going to keep my 1 unit. I don't know the B, but we're going to figure out the B. So this is really my ellipse. So from the picture, we get the C is equal to 2, because the foci, it has 0, 2. And the vertex, so because foci, 0, 2, that will give me the C. Vertex 5, 2. It means the A is how far we are from the center. It means A equal to 3. Now I need the B. C squared, now because everything is on the line parallel to the x-axis, it means the C squared is going to be A squared minus B squared. So I solve for B squared, it's going to be A squared minus C squared. Means that's a 4, I meant that's a 9, minus that's a 4 equal to 5. So the idea is just draw a little bit of a diagram and then everything will be spelled out for us. As long as we know that the A is how far we are from the center, how much the edge is from the center, and the C is how much the foci is from the center. That's really the idea. So finally, my equation becomes over A squared, which is a 9, plus over B squared, which is a 5, equal 2. Okay. Questions before we move to the hyperbola? All right. So hyperbola. So with the ellipse, a little bit of a summary for the ellipse before we move on. So the summary is that the equation of the ellipse centered at the origin, everything else is a shift, is x squared over, that's really the equation of the ellipse. And we split it into 2 cases, whether the A bigger than B or the A larger than B. If the A is bigger than B, then we have the foci on the x-axis. This is the foci on y-axis. Okay. And we have the C square is always A squared minus B squared. This is the largest one. So that's the summary of the ellipse. In this scenario, the ellipse is elongated vertically. From here to here, that's the A, and this is the B. And the foci is inside the ellipse. And in this scenario, it's elongated this way. The A always the same from the center to the intercept, and this is my B. Okay, so that's the equation of the ellipse. Now hyperbola. The geometry of the hyperbola is a little bit harder to explain. I tell you what the geometry is, but I will immediately give you the equation and we will actually analyze the equation. For the ellipse, the geometry was the ellipse where all the points that said the sum of the distance of the foci is equal to 2a. That's really how where this whole equation came from. The hyperbola is the following. What's the hyperbola? Okay. We fix 2 points, F1 and F2, that we are eventually going to call foci. So we fix 2 points, F1 and F2, and a number A positive, just like we did for the ellipse. The hyperbola is the collection of all points in the plane, xy, such that the difference from the point to F1 minus the distance from P to F2 is a constant. And we're allowing the constant to be plus 2a or minus 2a because we're allowed to flip the point. F1 and F2 will be called the foci. So the geometry for the hyperbola, if I want to draw it, is actually It's not easy. It's not like the geometry of the ellipse, but that's what's the definition geometrically. So what we're going to do, I'm just going to give you the equation of it. So using this definition, like we did for the ellipse, we can derive an equation, exactly like we did for the ellipse. I will just give you the equation and we study the equation instead of deriving the formula. So the equation of the ellipse. If the point F1, F2 are on the x-axis, then the equation is going to be the following. The equation will have the form. And on the x-axis, I will tell you what happened on the y-axis. The equation will have the form x squared over a squared minus, that's the main difference between it and between the ellipse. It's a minus y squared over b squared equal to 1. And the c squared for the hyperbola is not the difference between a and b, it's the sum between a and b. Okay, so that's going to be the equation of the ellipse. F1 and F2, those points, will have very nice reflective property that I will mention at the end. Okay, the same way for the ellipse. That's why we care about them, because they have very good reflection property that they are used in, building headlight and mirrors and stuff like that. All right. So what I'm going to do is analyze this. So how I am going to analyze this equation? Okay. So let us analyze the equation. X squared over a squared minus y squared over b squared equal to 1. All right. First, we're going to see what are the x-intercepts. Like I did for the ellipse, I'm going to analyze this slowly. What are the x-intercepts? It means where does this graph intercept the x-axis? All right. We intercept the x-axis when y equal to 0. That's where the intercept. So y equal to 0 will give me x squared over a squared equal to 1. It means x equal plus or minus a. It means when I'm going to graph this function, this equation, I'm going to graph it. The idea is how to graph this equation. When I'm going to graph this equation, the intercept at minus a and a. That's exactly what I did for the ellipse. The ellipse, I had a plus here. When I set y equal to 0, I get the minus a and a. So just to remind you, how did we get them for the ellipse? But let's see how things change immediately here. What are the y-intercept? When will the graph intercept the y-axis? Okay, we're going to set x equal to 0. Because that's what the intercept. What will happen if x equal to 0? If I put x equal to 0, what happened? I'm listening.
So then would it be y squared over b squared equals 1?
Minus y squared over b squared, right?
Yeah, sorry, minus.
It's crucial. Okay. Anything? Can this happen? Can this happen? It means y squared equal minus b squared. Is this possible?
No.
Absolutely not. Okay, because this is a positive number. It's a negative number. This cannot occur. Okay, this did not happen for the ellipse, because in the ellipse I had a plus, so I had a plus here, so we have plus or minus b where dy intercept. This cannot occur. What does it mean? It means when I'm going to sketch this equation, there is no intercept. It's not going to touch the y-axis, and that's very important. Okay, so things starting to look a little bit differently. Now I'm going to keep sketching this equation. I'm going to actually sketch it. That's really my goal. Okay, the way we're going to sketch it is we are going to solve for y in terms of x, because that's the only way we know how to sketch. It's such a complicated equation, so we're going to solve for y in terms of x. In terms of x. So I'm going to solve for y in terms of x, so I know what's really going on. So let's see. if I can, I mean, we will see. Minus y squared over b squared equal to 1. If I need to solve, it means I will have x squared over a squared minus 1 equal y squared over b squared. Am I right? I think so. Now, if I want to solve for y, I'm going to put this is equal b squared times x squared over a squared minus 1. So this will tell me that y equal. I mean, b, I can basically pull it out. Minus 1. What's missing? I'm missing one piece. I'm trying to solve for y so I can really interact with the equation better because I don't know what to do actually. I have to graph this. Now, what is the issue? What am I missing? Anybody can tell me what I am missing? Am I doing anything wrong? Anyone? Okay, if y squared equal that, it means y is plus or minus. Okay, so y squared is this, as when we're solving for y, it means y squared is plus or minus. It means that for every value of x, for each x, I have two values of y. For each x, I have two values. One, a positive values, one value for y, and I have the negative value. So how does this reflect graphically? What does it mean graphically in this problem? It means for every x, for each x, there are two y's that satisfy the equation, positive and negative. So for every x, 2y, it means if this point is on the graph, the point symmetric to it with respect to the x-axis will be on the graph. This is because of the symmetry of the graph. Okay, so if I know the top part, I know the bottom part. So the graph is symmetric with respect to the x-axis. Okay, also another remark before we actually graph. We are almost there. Another important remark. If I plug in x into the equation or minus x, what will happen quickly? Suppose I plug in 2 here, or I plug in minus 2. Will the y value be affected?
No, it won't be affected because it's a squared term.
Right. So how will this be interpreted in terms of the graph? The output at x and the output at minus x are the same. What does it mean graphically? It means the y for x, because it involves x squared, and the y for minus x are exactly the same. So what does it tell you about the graph?
It's going to be symmetric about the y-axis?
Exactly. It's going to be symmetric with respect to the y-axis because the output at x and minus x are exactly the same. So if this point is on the graph, this is going to be on the graph. If this point is on the graph, it won't be. This point will also be on the graph. So the graph is going to be symmetric with respect to the y-axis. So piece by piece, we're trying. So graph, symmetric, also with respect to the y-axis. We have total symmetry because the y value at x and minus x is the same. That's really the reason. So the y value at x and minus x is the same. So as you realize, I'm analyzing the equation instead of deriving it because it's actually more beneficial to you. Now the important part. I mean, there are a lot. The domain. What do I mean by domain? Whenever the equation or the formula involves a square root, we have an issue. What is the issue? Quickly, so we can finish hyperbola. Help me out. What's the issue? So when I solve for y, I got this term under the square root. So whenever we have a term under the square root, what is the issue?
It's going to be positive or negative.
We have to have it. Could it be negative? Can the term under the square root be negative?
No.
So what's going to be the domain? We need this to be positive. Absolutely. Okay, so this has to be positive. Otherwise, whatever under the square root is going to be negative. It doesn't make sense. What does it mean this is positive? It means I need x squared over a squared to be bigger than 1. It means x squared has to be always larger than a squared. It means the domain, the only x values that I can input are the x value that satisfies x squared bigger than a squared. So this tells me that my x, sorry, I have a stupid mistake somewhere. Anywhere I have any stupid mistake. Okay. Oh, sorry, I don't have any mistake. I'm sorry. What does it mean x squared bigger than a squared? It means x has to be larger than a. Or if you think about it, x has to be less than minus a. So the way x squared could be bigger than a squared if x is bigger than a or x is less than minus a. All right, what does it mean graphically for us? What does it mean? I go back here. Graphically means the only input value that x can have has to be bigger than a or less than minus a. It means if I pick any x in here in between and I plug it into the equation is not satisfied. If I plug any x between minus a and a, the equation will not make sense. So this means that the graph is going to be, there will be no graph here, no output here, no y value here. The y value will be bigger than a and less than minus a. Now the last step is we're going to graph this a little bit. Okay, so very important, there will be no graph. There is a gap in here. The graph will have a gap in here. And you get one piece of the graph this side and the other piece on the other side. Okay. Now the last piece for the hyperbola. So it's a little bit more involved than the ellipse, but we're there. Okay, the last piece is the following. Actually, let me start graphing and then I'll do the last piece. Okay, so this is the domain, important. Now, finally, how does the x behave? So as we realize, we have symmetry with respect to the x-axis, and I have symmetry with respect to the y-axis. So once I graph one part of it, then by symmetry, I can graph everything else. But now let us watch. When x increases, the y will increase. As x gets larger, x squared over a squared gets larger, minus 1 will get larger. So as x increases, y will actually increase. So the way it's going to look like is the following. At x equal a, y is 0. And then as x increases, y increases. So it's going to go look something like that. And then because of the symmetry, this will be exactly symmetric to it. And because we have more symmetry, it's going to be the reflection of it. And because we have more symmetry, we're going to have something like that. So this is the beginning of the graph. And there is nothing in between. If you take anything in between, there is no y value. Now, the other piece that we still need is the notion of an asymptote. What is the idea here? When I am graphing, my question is, how much shall I open this? I mean, how can I know whether I should go that much, I should go that much, and so on and so forth. So the question is, there is the notion of asymptote for the hyperbola. And what is the idea of an asymptote? So the last piece to finalize hyperbola is the notion of asymptote. Okay, asymptote, those are lines that tell us how the function looks like when x is very large. Okay, that tell us how the graph looks like. That's really what this asymptote looks like when x takes large value. So it means when here I start taking larger and larger x, how's the piece the graph looks like? Okay, I will tell you where the formula comes from, and then I will give you the formula. So let us analyze a little bit what's going on here. Okay, I'm going to analyze this piece right there. Okay, watch. Y is one piece of y, the positive one is this one. Minus 1. Okay. One piece. Then means that when x is large and positive, okay, then y, I'm going to do this estimate, which will explain the idea, the formula I will give you. It's almost equal to, if x is very, very large, like x is 1,000,000, I can basically neglect -1 in front of that. So it's going to be x squared over a squared. So when x is very large, y is almost equal to that. So if now considering x positive, this would be b times x over a. Mean that when x is very, very large, the values of y are almost equal to the value of b over a times x. So if I know the b and I know the a, so if I know I want the value of y, instead of using this complicated expression, the value of y is almost equal to the values obtained by b over a over x. Okay? And this motivates the asymptote. So the line y equal b over ax and the line y equal minus b over ax, because of the symmetry, those are called the asymptote. It means those will describe the behavior of the graph when x is large. Okay, and this is where they are coming from. They are exactly coming from the formula itself. Now I go back to the graph and I do the last piece of the puzzle. Actually, I will do it here. So I will sketch the graph one more time, the whole picture now, absolutely the whole picture. So we have intercept at A and we have intercept at minus A. Now, what does it mean? Those are the asymptote. It means when y is large, x is large, the values of y are almost the same as the value obtained by this line. So what do we do to sketch the hyperbola? Before actually sketching it, we sketch those lines. Y equal b over ax. So these are lines, they go through the origin, because if x is 0, y is 0. If x is a, y is b, something like that. And this is the asymptote. This is the line y equal b over ax. It stretches both ways. And minus, so this is the b, because if x is a, y is b, and then minus b over a would be exactly this line. So those are the asymptote. Okay. What does this asymptote tells me? It means when x is large, the y is right there. That's the importance of an asymptote. The y is right there. And now the graph would look like this. So we know the opening because that's going to be the graph of the hyperbola. There is no input between minus a, and that's going to be the graph in that. Okay, so that's really my hyperbola. So now let me summarize what we did and then start doing problem involving hyperbola. Questions? Okay. So we did a good analysis of the equation. And now let me summarize the whole picture. Okay, so summary for the hyperbola. Okay, summary. Equation of the hyperbola, I'm going to put two equations. So the first equation is foci on x-axis. It means the point F1 and F2 are on the x-axis. All right. Then the equation we'll have is the form x squared over a squared, that's the hyperbola, minus y squared over b squared, equal to 1. Okay, I'm gonna have two pieces, so we're gonna do it in front of each other. So, and here the foci on the y-axis. Now, if the foci happen to the y-axis, the equation will change in the following format. For the ellipse, it was a bigger than b, b bigger than a. For the hyperbola, the size of a and b will not matter. What matters is the following. If the foci happen to be on the y-axis, the equation would look like y squared over b squared. It means we start with y squared minus x squared over a squared equal to 1. Okay, so on the y-axis, the difference, the foci on the y-axis, the difference is that we start with y squared minus x squared. And this has happened on the x-axis. Now, the c squared is always the sum, regardless what scenario is. This will give us the, okay, so the foci. Okay, now the asymptote, the same equation. I will not change anything. These are the asymptote. Nothing changed. Plus or minus b over ax. In this scenario, we're going to have an x-intercept at plus or minus a, no y-intercept. And if you ever forget, you ask yourself, okay, is there an x-intercept? You put y equal to 0, you find the x-intercept. Is there a y-intercept? You set x equal to 0. Oh, there is no y-intercept. And here, that's the asymptote. Here, the x-intercept known. And y-intercept, x equal y-intercept, x equal plus or minus b. Another graph. And there will definitely a difference between the graph. In this scenario, the graph is like what we did a minute ago, the one we analyzed. The intercept, that will be called vertices here. Then we have those asymptote, and that's the graph. Okay, so the opening is right left. So sometimes we emphasize the idea of an opening. So the opening is right left, or left right, whatever you want to call it. Okay. Now, in this scenario, the graph would be a little bit different. It's just like you take this graph and you're going to switch it, you're going to turn it. That's how the graph looks like. The asymptotes are the same. Absolutely. And there is no y-intercept. Sorry, there is no x-intercept. The intercept are here. That's the b. That's the minus b. b minus b. And in this case, everything reversed. The opening will be up and down. That's how the graph will be like. So opening, up and down. Now, another word that we will use is the vertices. The vertices are those points. Those are called vertices. And in this scenario, the foci, because it's a squared plus b squared, is going to be bigger than a. The foci would be right here. So this is the foci. That's C0. And this is going to be inside. Minus C0. Okay, so that's, and in this case, the foci will be inside here. So that would be the 0C. And that would be 0 minus C. Okay, so that's a summary of the hyperbola. And now we just, like we did for the ellipse, we're just going to do exactly the same thing. Just a bunch of examples and proceed. So question before I go. So that's the whole summary for the hyperbola. And these are the lines. This is y equal b over ax. And the same here. B over ax. And that's the minus 1. Right. So now let us practice those and draw hyperbola. So this is the equation. Again, it has to be kind of really drilled in your head. because you will use those. If you had a plus, that's the ellipse. If you have minus in between, that's the hyperbola. Okay. Now the difference here on opening left and right, the x squared comes first, then the minus. Here, the y squared over b squared, then the minus in between. So that's really the change between them. All right, so let us do example 1, 2, 3 here. So example number 1. Okay, determine the foci vertices and asymptote and sketch. Okay, so everything. All right, so this is my equation, x squared over 4 minus y squared over 9 equal to 1. There is a minus, that's a hyperbola. Okay, and this hyperbola, the opening is going to be, so opening is going to be left, right. All right. So they want me to find the foci, they want me to find the vertices, the asymptote, and the sketch. So let's do it then step by step. The foci, it means I need the c square. For the hyperbola, c square is 4 plus 9, which is the sum, which is equal to 13. So the foci would be, so we start building the graph slowly, slowly. The foci will be somewhere here because we're starting with x squared. So they're going to be plus or minus the square root of 13 and 0. So these are the foci. Now the vertices. The vertices are, in this case, it's basically when the y equal to 0. So the vertices here, we're going to take A is 2. The vertices are going to be, these are the vertices, these are the intercept. So 2 right here and right here, this is the 2. So this is minus 2 and this is the 2. So the vertices are going to be plus or minus 2 and 0. Now the asymptote. We have 2 of them, plus, one is plus, and the other one is minus, b over a x. So now we have to define each one. So y equal plus or minus, my b here is a 3 over 2x. So we have 2 of them basically. So we have 2 of them. We have one asymptote, the positive one, and we have the negative one. Okay. So now we sketch. For asymptote, for hyperbola, to sketch them well, the first thing we do is we sketch the asymptote, which are just lines through the origin. Once I sketch them, I know how much I need to open my hyperbola. So right here now, I'm going to sketch the line. So y equal 3 over 2x. I want to sketch this line first. All right. First, it's a line that goes through the origin, because if x is 0, y is 0. We're going to go through the origin. The other point, sketching a line, we have to sketch 2 points. The other point that is always good to take is the point x equal to 2. If x equal to 2, y equal to 3. That's another point. So these are the asymptote. Okay. Now, minus 3 over 2 is just the one symmetric to it. So that's the minus 3 over 2. So we're going to sketch that. So these are only the asymptote. It means the behavior, how the graph looks like when x is large. And now the graph. These are the vertices. The graph looks very much like this line. And then everything else is symmetric. Everything else is just a bunch of symmetry. So symmetric. And then it looked like this line. That's what happened when x is large. end of my graph. At example number 2. Please, if I'm going fast or I'm moving, please let me know. Again, determine vertices, foci, and asymptote. Okay. All right, so 2y squared minus x squared equals 4. Okay. Now, like we did yesterday, we saw the standard equation of the hyperbola. So that's what we call the standard equation. So if something looks like could be a hyperbola, but not in standard form, we like to write it in standard form to be able to find vertices, foci, and so on and so forth. So we're going to divide by 4 to let it look in the more standard form. This will give y squared over 2 minus x squared over 4 equal to 1. All right. Now, the first thing here, we always ask ourselves, basically, is it opening left, right, or opening up and down? And this will, or another way to set this up, are the foci on the x or y axis, or are the vertices on the x and y axis? That's really 3 questions which are the same answer to them. Since we are starting with y squared here, it means when I'm going to graph that, immediately there is no x-intercept, because if y is 0, this doesn't make sense. So there is only y-intercept. So the vertices are going to be right here on the y-axis. The opening is going to be up and down, but you have to do it carefully. And what else? The foci are going to be on the y-axis as well. So let us find the vertices. What gives us the vertices are the 2 here. So we're going to have b squared equal to 2. B is plus or minus the square root of 2. So the vertices are going to be plus or minus square root of 2 and a 0. So this is going to be one vertex. And this is one vertex. So here immediately we're going to say that's opening up, down. Okay. Vertices on y-axis.
Is it 0 square root of 2?
Oh boy.
Instead of...
Oh boy, oh boy, oh boy, oh boy, oh boy, oh boy, oh boy. Thank you very much. I'm allowed to do this mistake. You're not.
All right, sounds good.
All right. If you do it, you get hit. I don't. All right. Thank you very much. All right. Now the foci. Okay. The c squared, the formula is the sum equal to 6. So c is the square root of 6. So the foci are, okay, I will not do the same mistake twice, plus or minus the square root of 6. So they are somewhere in here. Okay. Now, finally, I need the asymptote so I can have like a decent graph for the hyperbola. So finally, the asymptote y is plus or minus b over ax. It means plus or minus. My b is the square root of 2. My a is 2. X. So I have 2 asymptotes. One is the positive square root of 2 over 2. And one is the negative, the square root of 2 over 2. Okay, so let's do them. There are lines, they go through the origin. Absolutely important, they go through the origin. Now, another point you can take, if x is 2, I take x equal to 2 because it's nice. If x equal to 2, y is the square root of 2. So we know that this is square root of 2. So if this is 2, that's a point on the asymptote. I draw my asymptote. Okay, and I draw it. Once I draw 1, everything else is symmetric. And now the only difference here is that you have to be very careful. My graph is going up and down, up and down. And that would be my graph. Okay. All right, the only thing which we still have to do, and of course I'm out of time, is the same thing we did with the ellipse. We shift hyperbola. And when we shift them, basically it's like taking this hyperbola and changing the center. That's really what the shift is. So the equation, so shifted hyperbola, I'll give you the equation and I stop right there. So shifted hyperbola. Okay, and those, the equation would be x minus h squared, exactly the same, minus y minus k squared over b squared equal to 1, or those are flipped. It means y minus k squared over b squared minus x minus h squared over a squared equal to 1. And the rest is almost the same as we did before. So, so those would be like, this one would be a hyperbola, that will be the center, and everything else is the same. We're going to have two asymptote, and we're going to have opening this way. And from here to here, that's the A. And in this case, again, the center will be HK. But in this case, we're going to have the vertices here, the asymptote. But this is going to open like that. So everything will be the same, but we shift everything. Everything is going to be shifted. Okay, so I stop right at this stage. I'm going to assign problems for tomorrow with this section. Those with shift, you may have trouble doing them. You do your best, and I talk about them tomorrow. Okay. All right. With this, I basically wrap up the course in terms of new material. I will not give you any more new material. Tomorrow, I will work with the shifted hyperbola a little bit. And okay. All right. And what else? And that's it. So I'm going to assign, the problem assigned for tomorrow is the spring problem and the cylindrical shell volume. And I will be assigning more work problem for Friday. And if you guys have any questions.
Is there going to be some assigned on Brightspace like yesterday?
Yes, exactly. Exactly. Okay. Yeah, that's the only way you're going to learn it. As you guys know by now, the only way to learn is to do those homework. And Freddie is asking me, are we having a quiz on Friday? And the answer is yes. Any other questions? I have to make sure you know those conic sections. Any other questions?
Yes, one question.
Yes.
How should we submit